students. On the last term I had finished a very important chapter, that was electrochemistry, unit 3, and we had done some very important things there. Electrolytic conduction, the Nernst equation. Remember all these things well. Remember all the formulas, remember the units, and practice the numericals. Let us now come to the unit 4, that is chemical kinetics. Before we start any chapter, we have to read about it. What is chemical kinetics? So, we see here the branch of chemistry which deals with the rates of chemical reactions and the mechanisms by which the reaction proceeds is called chemical kinetics. Remember, there are some factors which affect the rates of chemical reaction. What are those factors? The factors which affect the rates of chemical reactions are nature of reactants, concentration of reactants, products and catalysts, temperature and pressure at which the reaction is carried out. Now, coming to an important topic, that is rate of chemical reaction. How do you define a rate of chemical reaction? Rate of chemical reaction, it is a measure of the speed with which the reactants are converted into products. It may be defined as the change in any one of the reactants or products per unit time. Very, very important thing. This is per unit time. I underline this. Now, consider a hypothetical reaction. R giving you P. What is R here? R is the reactant and P is the product. Now here, R turned into P, in which 1 mole of the reactant R produces 1 mole of the product P. The rate of above reaction, and this reaction can be expressed in 2 ways. What are those 2 ways? Number 1, the rate of disappearance or decrease in the concentration of R, or we can write mathematically rate of reaction is equal to decrease in concentration of R upon time taken. This is equation number 1. Number 2, rate of increase in the concentration of P, that is rate of reaction is equal to increase in concentration of P. This is question number 2. Now, if R1 and P1 are the concentration of R and P respectively at time T1, and R2 and P2 are the respective concentrations at time T2, then delta T is equal to T2 minus T1. Delta R is equal to R2 minus R1 and delta P is equal to P2 minus P1. Where the square brackets, these are the square brackets, express the concentration in moles per liter, and delta R and delta P are the changes in concentration of R and P during the time interval delta T. The rate of reaction will be expressed as ROR, that is rate of reaction is equal to minus delta R over delta T, or ROR is equal to delta P over delta T. What do you mean by this? By this you mean that with the passage of time, the concentration of the reactant decreases.